Hello everyone. We'll make a start. I don't think we've quite got everyone logged in yet, but no doubt they'll join us if they're attending. So, what we're going to tackle this week is kind of a little bit of modelling practice, which is always good to do. And then ultimately, we're going to lay out at least two drawings. We may do a third, depending on how quickly we progress through the tasks. So the content that we're going to work through is in the learning materials section of the site where we've been working before. And you can see I've put a new section in there called SolidWorks Drawings. And if you click on these top two PDFs, so if you get those open in a separate tab in your browser, you can see they're fairly simple parts. Both drawings show you these fairly simple SolidWorks models. But the task that we're going to sort of work through is that we're going to model these parts up initially. So we'll do one part and then create the drawing for that part. And then we'll model the second part and make the drawing for that part as well. So we're getting that practice in sort of general modeling skills. We'll be using extrudes, we'll be using fillets, we'll be using a lot of sketching, techniques that maybe you have used in sketches before, maybe you haven't used. Breaking parts down sort of before we begin modeling them. So that's looking at drawings like these or engineering drawings of any kind, kind of having the ability to break that part down in your mind and come up with a modeling strategy. So a kind of rough list of features and where you will begin and how you will gradually build up the actual part model itself. So I think we'll begin on this first one, this offset link. And then when we've created the part, as I've said, we're going to create this drawing. We're going to try and get as close as we can to replicating this particular drawing. And I think, having done this exercise with some groups last year, we pretty much were able to replicate this perfectly. So yeah, what that will include in order to do that, just give me a sec. So what that will include is coming up with our own specific title block as well. So you can see down here, we've got the title block of this drawing. This is a kind of a non-standard title block. It just contains the information that we're particularly interested in for this drawing. So the way that that gets created is you load in one of the SolidWorks standard title blocks and then you modify that and adapt it to your own purposes. So that's a good skill to be able to have, because you don't want to have to be locked into just using the standard SolidWorks formats all the time. Sometimes the title blocks that you get in the SolidWorks standard sheets are way too big and they take up a lot of space on your sheet that can be used for sort of drawing views and annotations and things like that. The second part that we're going to tackle, I haven't actually adjusted the title block on this one. So I believe this one, keep clicking on rotate there, sorry. I believe this one is just the ANSI standard title block. So you can see that title block on that drawing that we were just looking at before is kind of a modified, cut down version of this with a few kind of additions as well. So we'll look at how to modify the actual sheet formats themselves, which includes the title blocks, and then we'll practice laying out drawing views. I think we did a little bit of this when we did the valve revolved part, but it's always worth kind of having a bit of a practice on some different parts because you encounter kind of different problems depending on what the part is that you're creating the drawing of. So yeah, that's the plan, to do a bare minimum of those two. If we kind of rush through those really quickly, I think what we'll tackle is a simple assembly drawing. So you can see this is just a simple 3-part assembly. It's got a bill of materials that gets auto-generated by SolidWorks there. Again, there's some customization to the actual title block that's gone on there, and various types of views. There's a assembly section view there. Obviously, that shaded view on the left there is an exploded assembly view, which is a specific type of view that you can only use in assemblies. And then we've got things like detailed views and standard projections and things like that. So yeah, if we get through these first two, I think we'll tackle that one. And even if we don't, we'll probably tackle that one next week. And then I think we'll lead into having a little look at simulation in SolidWorks sort of next week. So that's the plan. So if you want to get that PDF open so that you can refer back to it yourself. And before we kind of begin modeling this part, in terms of breaking this down kind of mentally before you begin, you kind of have to group the geometry into features that you recognize, I would say. So the way that I modeled this part in the first place was I created two extruded bosses, or extrude boss bases. One with a kind of tube shape here. So I'm sort of tracing that with my pointer. So that's the larger tube. And then there's a smaller tube, which is a distance away from the larger tube. And obviously it's oriented at 90 degrees to that first tube. And then when the two tubes are being created using the extrude feature, then there's a kind of almost a rib of material that joins the two together. So there's again, just a simple extrude feature to create the sort of main bulk of this rib. And then the sort of ancillary features, or the features that you can apply to existing geometry, include two different sizes of fillet. So it might not be obvious, but there's a large fillet here. So that section there that I'm pointing at is a large fillet, which we can find the size of. There it is, radius 50. So that gets applied to both sides of the part. And then there's lots of edges that have been filleted using this highlighted red fillet here. And again, we've got a size for that somewhere. Here we are on the drawing. So all the red fillets, a radius of 4. So in this case, the sort of decision to use a shaded style of drawing kind of has a practical use, because it means you can highlight certain features, in this case that fillet, so that you don't have to create arrowheads that point to every single occurrence of it. So you can just say everything that's pictured in red is all a fillet of radius 4. So there's some kind of logic behind using the shaded kind of drawing style here rather than just simple line drawings. So yeah, the general order that we're going to do it in is large tube using the extrude tool, small tube using the extrude tool, put a piece of material between the two, again using the extrude tool, two large fillets there, and then multiple small fillets. And then the final little bit of it is just to cut this keyway. So that would be, on this sort of design, that would be a little slot that's cut in the internal bore here, and then no doubt there's a shaft that's going to fit inside that, and the shaft would have kind of a matching cutout. And then what you would do is you would sort of insert a piece of metal known as a key. So you would stop this linkage being able to spin relative to the shaft that's in there. So yeah, the final bit will just be a simple extruded cut just to put the keyway in. So that's kind of, I've already broken this down for us. So that's kind of the order of features that we're going to use to actually create this. So I'm going to pull that across onto my other screen and then drop into the SolidWorks interface. So this should be easy by now. So we're going to create a new part. So click on the new icon at the top there. What do we want to create? Part. So I'll just double click on part. Just as I'm doing that, I'll put my on-screen display bit of software on so that you can see what I'm clicking on and see what keys I'm holding as well. So that'll pop up at the bottom left now. So I'm not really going to go through, if you can't see the base planes, how do you show the base planes? We kind of do that every week. So it's generally in that hide and show all types. So yeah, we've covered that a few times. So I'm going to assume that you can see your base planes before we begin. So I said we're going to use the extruded boss base feature to create this lower tube. The only thing that I haven't kind of told you yet is what plane are we going to use. So you kind of have to make kind of a as sensible as possible choice as to what plane is where in terms of our part, and there is no right and wrong answer. But for my mind, this I'm regarding as the front of the part. So when I'm looking at it from this view, or from this sort of angle, I'm going to regard that as I'm looking at the front of the part there. So I'm going to create my circular sketch to create my tube on the front plane if I'm looking that way. So again, there's no real right and wrong to that. It's just you've got to make a choice, and that's the one that we're going to use. So extruded boss base, the system asks you what plane do you want to create your sketch on, front plane. And all I'm going to sketch are two circles. And I'm going to center them both on the origin point. So we want to use that center circle tool. So there's two different types of circle tool in there, but it's the center point circle that we're using. And then I'm going to hover over the origin until I see that yellow coincident icon appear, which means the system's actually going to lock that first point onto the origin point, which is what I want. And then I'm just going to drag it out. I'm not too concerned by the size of this, so I'll drop it about there, and then I'll do the same again for the slightly smaller circle. So make sure the center locks itself onto the origin and click, drag it outwards, and then click again. Then we don't need the circle tool anymore, so you can press escape. We're going to add some dimensions to it, so we're going to use the smart dimension tool. And then I'll probably do the first circle first. And this, it may seem to make no difference at all, but when you apply this diameter dimension to the outside circle, it would be my advice to make the system. So you can see, as I'm dragging this dimension around, there's various different versions of it that the system is offering me. There's an angular one there, and then there's a horizontal one there, and then there's, vertical one there, and then there's a horizontal one there. For reasons that kind of will become clear later on, I recommend you insert a diagonal one or an angled one like that. It's just a quirk of the system. Even though that one, the vertical one, and that one, the horizontal one, both have the diameter symbol in front of them, so it would be reasonable to assume that you were dimensioning the diameter of the circle. You're not in that case. You're dimensioning what's known as the horizontal extent of it, and there you're dimensioning what's known as the vertical extent of it, which is subtly different. And for our purposes, because we're going to produce drawings from this, it is better if we get a true diameter, which is that one. So place the dimensions so that it's on an angle rather than locked to vertical or locked to horizontal. So we'll drop that dimension and we'll set it at what it needs to be. So it needs to be 80 millimeters. And then we'll do the same again for the inner one. And again, don't let it lock itself to vertical or horizontal. Sort of drag it into a position where it goes into that kind of angle dimension mode like that. And the inner one is 50. So we've got our close sketch that we need for our larger of the two tubes. So it's shaded it in. It's actually a bit misleading because it's shaded in the center of this one as well, which we know that that's going to be hollow, that little center section. But we're happy with that. It is fully defined, and we're happy that it's actually going to fill in the gap between the two circles with material, not fill in the center. So we can OK that sketch. and we get our preview of what the extrude's going to look like. If you want to kind of rotate around to see which direction it's going away from the plane, that's sort of advisable at this stage to try and figure out whether you're happy with that. Again, I've already kind of made these choices in my head as to how our part is positioned relative to the base planes. And the decision that I'd made that this 80 millimeters depth that we're about to set for this extrude goes into the kind of negative side of the front plane. So currently it's on the positive side, and if you want to figure out which side is which, if you look down at the bottom left there with that tri-axis readout that should always be down at the bottom left, the arrows are generally agreed that they're pointing in the positive direction. So we're going positive Z at the moment with this extrude. And I'd kind of made the choice in my head that I wanted the front plane positioned on my part there, on that vertical face. So I'm going to have to flip the direction of this extrude in order to achieve that. And again, that's not a right and wrong sort of decision. It's just you've got to decide these things. I made that choice when I was looking at the drawing, so that's what I'm going to do. So I'm going to flip the direction of that extrude, or reverse the direction to use the correct SolidWorks term. And then I'm going to set the amount of extrude that I want, so the depth, which we just saw was 80 mil. And then that looks okay. I'm happy with that. So I'm going to click on the green tick to OK it. So I've got my first feature. That's the lower tube, the bigger of the two tubes. Now we're going to tackle that upper one, that slightly smaller one. And again, looking back at the reference material, you can see that the upper one is at 90 degrees, or it runs at 90 degrees to the lower one. So we're going to have to create the sketch on a different plane. And given that the front plane is now sat up against that front face, so that leftmost face on that lower tube, we're going to have to sketch this one on the right plane. And more than that, if we look down from above onto the part here, the upper one is kind of centered around the center line of the lower one. So it must be a mid-plane extrude. So when we come to actually create this upper extrude, when we've created the sketch, we've got to remember that it's going to be a mid-plane extrude. So let's do that. So extrude boss base, which plane? The right plane, which you can see there. Doesn't matter that the right plane doesn't extend up to the point in space that we want to sketch. The right plane and all the planes are essentially infinitely large, so you can sketch anywhere on that plane. That boundary edge of the plane is just for tidiness, I suppose. It's to tidy up the display of your part so that the planes don't go off into infinity in every direction. So, two circles again. So, center point circle tool. Somewhere up here will be fine. We're not going to lock these centers to anything in particular to begin with. We're just going to lock them so that they share a center point. So the first circle, if we just roughly sketch that in, and then the second one, we want to lock its center point to the center point of the first one. So when you hover over the center point of the first circle, you get that concentric relation popping up in yellow. So when you get that, you want to click. Now the center points are locked together, and then click again to drop the size of the second circle. And then we'll add some dimensions to these. So smart dimension again. We'll do the outer one first. So again, I'm making sure that my diameter dimension is a true diameter by holding the dimension to kind of diagonal. I'm not letting it lock itself to vertical like that or horizontal like that. I'm making sure that it's on an angle. So I know it's a true diameter then. And this one is going to be 50. And the inner one is going to be 30, like that. So we will position the kind of horizontal and vertical position of these two now, because you can see they're both still fully blue. So they both have degrees of freedom that mean they can just slide around in this sketch horizontally and vertically. So we're going to put some dimensions in that will position them relative to this lower tube. And again, if we just go back, have a look at the dimensions that we're about to put in. So there's a 40 there, and that's from the sort of rightmost face on that lower tube. That's 40 horizontally. And then there's 100 there as well, which in the drawing comes up from the center axis, or the center line of the lower tube. Now, because of the way that we've created that lower tube, or the position that we've created it in, that center line happens to be coincident with that plane there. So that's quite good, because we can reference that plane with our smart dimension that we're about to create. So smart dimension tool, click on the plane, click on the center point of our two circles, and then place the dimension just so it's as legible as possible. And that one wants to be 100. And then we'll do the same again, but for the horizontal dimension. And this time we're referencing this vertical rightmost edge on the lower tube. So that edge there. Click on that, and then click on the center point of the two circles again. And then one final click just to place the dimension. And that should be 40 mil. So at that point, we've fully defined the sketch. It is a closed boundary. So we're happy, but we're not quite going to exit yet. And the reason we're not is that because of the way that we're going to make the drawings, when we come to replicate this drawing, we're going to try and import as many of these dimensions into the drawing as possible. And when I say that, I mean, rather than create them ourselves whilst we are laying out this drawing, we're going to tell the system to just import them straight out of the part itself. So straight out of the sketches that went into creating the part. And you can see that dimension that I've highlighted there is not displayed as a diameter. So it doesn't have that diameter symbol like this one, like the 30. It's actually displayed as a radius, which is a perfectly valid way of doing it. But the one that we've put on our sketch, if we get our sketch back, is displayed as a diameter. So the way that you change that is to right click on it, and you can see there, one of the options is display as radius, which mine hasn't updated, and it didn't update the other day for whatever reason. Let me try that again. Right click, and now you have to find that option. It's down here under display options, display as radius. So you might have to try that a couple of times as well. I ran this the other day, or a similar sort of drawing, and it worked. And then I ran it the day before, and it didn't work. So yeah, mine's working now. But you may have to try maybe twice just to get the system to change that. But what that means is we are laying out these sketches with a sort of eye on creating the drawings of this part later on. So we're putting sensible dimensions in that we intend to reuse when we come to create the drawings. So it's kind of minimizing work down the line, either for ourselves or for whoever gets to create the drawings of the actual part. So we're happy with that sketch now. We can exit the sketch, so okay the sketch. Because I temporarily quit out of the feature there, I'm not confronted with the extrude boss dialog now. Hopefully you didn't have to quit out. I quit out because my system wasn't updating that diameter value to a radius. So what I'm going to do now is I'm going to quickly jump back into the extrude feature. Hopefully this is what you're seeing. Something like that. As I say, that's what happens if you cancel a feature. The system keeps the sketch that you've just created, but it it cancels the feature. So you don't drop into this feature creation dialog on the left hand side. You just exit the sketch that you're in, and the sketch just appears in the feature manager, just as an orphaned sketch, you'd sort of call it. But anyway, I've gone back into the Boss Extrude feature. It's accepted that sketch that I've created as valid input to create this feature from. It's not a mid-plane feature, so I'm going to change that straight away. So I'm going to change from blind to mid-plane. It looks a little bit too wide, and it is, so that depth needs to be changed to 50. And then again, it's probably wise just to have a quick look at it, see whether it looks correct. Yeah, it looks like it's in the center of the lower tube in terms of its orientation. So I'm happy with that. So I'll click on the green tick. So we've got kind of the important bits, I would say, of this linkage. The bits that are going to interface with the rest of the assembly that this thing is undoubtedly going to be used in. So there'll be a shaft of some kind that kind of sits in there and joins that end of the link to the rest of the whatever the machine is that it's part of. And then there'll be another shaft that sits in this lower link that has a keyway cut into it that somehow joins it to the rest of the machine in this direction. So these are kind of important pieces of this design. The bit that we're going to do now is kind of the joining section in between them. So it's the bulk of material that makes sure that this end doesn't move relative to this end, or doesn't move much, let's say. There will always be a little bit of flex in there, no matter how you design it or what material you build it out of. So again, referring back to the drawing, this rib or this piece of material that's going to join these two together, it is centered around the kind of same plane that this upper tube was just created around. So we created that extrude on the right hand plane and just use the mid plane extrude for it. So we're going to do the same thing for this kind of joining shape as well. So that's the plane that we're going to create it on. It is just going to be an extrude again. It's just going to be an extruded boss base. But what form is the sketch going to take? So it's this view down at the bottom right that we're going to have to look at. Essentially, I interpret that that view and those particular dimensions that are pointing at this shape. So there they are. There's a radius 200 and a radius 50, and then there's an odd one down there that's just a radius. It doesn't define what the radius is. It just basically says, so when it says R or radius, they've shortened the word radius there, it just means that edge there, or that piece of the part, is a section of a circle, yeah, is an arc essentially. So that's the only bit of information we have about the lower one. So this piece up here is an arc of radius 50, and it joins on to this piece here, which is an arc of radius 200. And then there's no other sort of annotation describing the shape that we have to create as a sketch. But given that there's no other annotation on that drawing view, the assumption that you must make is that this lower arc runs into that vertical face with no discernible kind of notch or no discernible angle between the end of the arc and the vertical face. So that arc ends at vertical. And the same up here. You assume that this 200 radius arc runs into the perimeter of that upper circular shape there. And there's no discrepancy between the two. Where the arc ends in terms of the angle that it ends at runs perfectly into the edge of that circular shape. And we have a word for that in sketch terms. It's tangent. So the end of that arc is tangent to that circular shape, and the end of this arc is tangent to that vertical edge. And then the final one, the two arcs meet each other, and the two arcs are tangent to each other as well. So we'll tackle this top section first, this double arc section. So what we're going to have is a tangency relation on this end of the arc, a tangency relation where the two arcs meet each other, a tangency relation where it meets the edge of this top tube up here, and then we've got two radiuses that we can apply to the actual arcs themselves as well. And with all that applied to the sketch, that section of sketch should be fully defined. And then we'll tackle this lower one after we've done that. So let's do all that now. So it's going to be an extruded boss base again. So we'll select that. It's going to be on the right plane. And again, I'm sure we covered this last week. My system is now auto-rotating my view round every time I create a sketch. I'm sure we went through that the other week, how to switch that behavior on. But if you're not seeing that behavior on your system, then you have to manually, each time you create a sketch, go into that menu there and do a normal 2. Or for the eagle-eyed people, you can see there the shortcut is the control key and number 8. But they're sort of a decent distance away from each other, so it can be a bit tricky to hit that. So back to the sketch. The first thing I'm going to do is I'm going to hide the planes because they're kind of obscuring something that I want to click on. So the thing that I want to click on is the point here where the top edge of that tube meets the vertical edge of the tube, and I can't actually click on the point because the system thinks I'm trying to click on that plane instead. So I'm just going to hide all features that aren't solid blocks of material. So I just click on the eye at the top there and it just hides everything. Then I'm going to get my arc tool that I'm going to use. So the specific arc tool that we're going to use is the 3-point arc. So if you've not got that selected at the moment, it's just in that drop-down menu next to the arc tool. And then I'm going to let the system lock one end of this first arc onto that point that I was just talking about. So the point where those two edges meet highlights in orange when you go near it. So I'm going to click there. I'm going to make this first arc about that sort of scale relative to the rest of my part. And then I don't want to put a huge amount of curvature upwards in it. I just want to ensure that it's not kind of convex, so it's not sagging like that. I want it curving that way, so curving upwards slightly. But as I say, I don't want it too curved like that. I just want to put a subtle upwards curve in it. Something like that will do fine. And then, because I've still got the arc tool selected, my next click is going to begin the second arc, or sketching the second arc. And I want to lock the first point of this second arc onto the end of that first one. So again, when I go near the first one again, I get that concentric relation showing up in yellow. When I get that, I click. And now the first point of this bigger arc is joined onto the end of that first arc that I created. And then the other end of this larger arc, I just want to stick it or add a relation between it and the edge of that upper tube. And you can see when I kind of go near the edge of that upper tube, the kind of compass points are shown. So north and south and east and west on that tube are shown. I don't want to stick the end of this arc onto any one of those specific points. I just want to lock it somewhere on the edge of that upper tube. So there will be just fine where I've got it at the moment. And then again, I just want to put a little bit of upwards curvature in it, because eventually it will have upwards curvature. It won't be curved like that, sort of in a downward sense. So I just want to put a little bit in it. That's good enough for now. Then I'm not going to sketch any more arcs, at least for a little while. So I'm going to hit the escape key to get out the arc tool. And then if you hit the escape key again, it deselects this upper arc. So you can see it's highlighted in sort of a pale blue at the moment, which means I've still got it selected. So if I hit escape again, it deselects everything. And then what I'm going to do is I'm going to try and drag the positions of the ends of these arcs approximately into their final position that they're going to end up in. So for this, you kind of need to be you kind of need to have one eye on what you're aiming for. So what I'm going to try and do here, I'm going to try and lock this window so that it stays on top. Yeah, it's working. So we can see that over on the left there. We're trying to get somewhere near that shape with our sketch here just by clicking and dragging the endpoints. So I'm going to drag this top one. Again, I don't want to lock it to perfectly at 12 o'clock or at north on the compass point, because that would be the wrong point in our case. I'm going to drag it to about there. That's good enough for our purposes. And then this lower one, there's no option for dragging the point on that because it's locked itself in position. But what I can do is I can drag the meeting point of these two. And you can see as I move that around, there's a little X mark that is rising up through that lower tube. And I know that when this lower arc is correctly sort of positioned and dimensioned, that which is the arc center point, so that we've said this arc is a portion of a circle, all circles have a center point, so that is the arc center point for this lower arc. You can see it moving up and down. I know that when this arc gets locked in position, that center point should be approximately on that horizontal edge of that lower tube. So where I've got it there is approximately right. So I'm going to just let go there. So I'm reasonably happy with that now. And the reason I'm bothering to do all this and not just add my dimensions and add my relations is that with sort of slightly complicated bits of geometry like this that these two arcs are, when you start adding relations to them, you can get strange things happening. And I'll try and simulate what I mean now, so you don't do this step. So you can get things like this happening. Let me put a tangent relation on this upper one. We'll do this together in a second. But so now I've just added a tangency there. Yeah, things like that. So that's a good example. So sometimes when you're adding relations to a sketch or you add a dimension, you can end up in situations like this or similar to this. And it becomes difficult to get back to where you were then. Now, luckily, we've always got the undo key. But this is why I was trying to drag these points so that they approximated the final positions that this sketch needed to be in. And hopefully what that will mean is as we add the tangent relations in now, which is what we're going to do in a second, the sketch shouldn't turn itself inside out or upside down or all those crazy things that we don't want. So let's add these tangency relations in. So let's put one between the two curves first. So I'm going to click on the upper curve. Just make sure that you don't end up clicking on the exact center point of the curve or the exact midpoint there. You can see it just appearing underneath my point. That's not what you want to select. You just want to select the curve itself. So select the curve, hold down the control key, select the lower curve, and again, don't be tricked into clicking on that dead center point. That's not what you want. You just want to click on the sort of curve itself, and then we can add a tangency between them. So there's a tangent relation icon there. Yeah, that looks okay. It didn't pull the sketch inside out. Let's put one on the lower curve. So we'll click on the lower curve again, get that selected, hold down control, and select that vertical edge there. And then tangent. And you can see it barely moved because I took the time to drag that curve into position so its center point was coincident with that top edge, which hopefully if you realize that this is a portion of a circle, then you realize that when the circle gets to that point there, if it has to run into a vertical face or a vertical edge there, then the center point must be coincident with that top edge. It just kind of stands to reason. Because you're at, working with a clock face, you're at 9 o'clock there on the clock face. So the center point must be there. So let's put the final tangency in. So I'm going to select the upper curve again, hold down control, select the outside of that tube, and then add a tangency between those two as well. And everything seems to have gone well. Hopefully yours has gone equally as well. Now what we're going to do is put the smart dimensions on. Just in case anyone's sketches have turned inside out, I'll just try and break mine on purpose. Yeah, something like that may have occurred on yours, which, to give the system its dues, it's still satisfying all the relations that we've put in there. So that lower curve still ends at vertical, so it's still tangent with that edge there. These two are still tangent to each other where they run into each other. There's no discernible notch or difference in their angle. They just run smoothly into one another. And again, that tangency between the end of the big curve and that upper tube is still maintained. So the system's not broken any of our rules that we've given it there, but it has come up with a shape that is of no use to us whatsoever. So yeah, just be aware that that sort of thing can happen when you're setting up these slightly more complicated sketches, let's call them. But anyway, if you do get into that problem, click on undo to get back to sort of a more sensible sketch and try and drag it into position before you put the relations on it. So let's put the smart dimensions on this. So smart dimension on the upper curve, I think that one is 200. And then I'll just double check that we're doing the right thing here. So yeah, 250 for that one. And then all of the lines and points there should turn from blue to black because we've fully defined those two curves now. And we can put this lower one in. So let's have a little analysis of what we're going to do here. So the fact that this drawing has not specified what this radius is, again, we kind of have to do a little bit of a detective work here. It's all governed by tangency relations again. And what we can deduce from this is that, yes, this is a portion of a circle because it has a radius sort of indicator there. It is a piece of a circle. So that's the first piece of information that we can be sure of. There's no kind of reference to where this arc meets the edge of that tube. So again, I'm going to assume that that means it's tangent to the edge of the tube. There's nothing on the drawing telling me otherwise, and this is kind of what you've got to assume. So it's tangent to the edge of the tube there, and it's also tangent to this vertical edge here as well. Very similar to the way that this one was. So when you lock the two ends of this arc shape to the edge of that upper tube and to the top point on this lower tube, the top rightmost point on the lower tube, and you apply tangency to either end, you don't then have to specify what the radius is, because there is only one radius that it can be and satisfy those constraints or those relations. So that's what you're meant to assume when you see something like that on a drawing. If you see no references to how it runs into this shape, you assume that it runs into it tangent, and that has a special sort of significance then. It means that it's holding it in a specific position and size, so you don't really need to specify its size. So yeah, let's put that one in. So it's a single arc this time. So we'll get the 3-point arc tool back. We'll lock the first point there onto that point on the lower tube that's highest point and rightmost point. There. We'll drop the second point so it just locks itself onto the edge of the upper tube. Again, we don't want to hit a specific point of any importance. We don't want to hit south there on the compass sort of face. We just want to stick it to the edge like that. And again, we'll give it a curve in the right direction. So we know it curves upwards, so we'll give it a little bit of curvature in the correct sort of direction like that. Then I'll hit escape twice just to get out of the curve tool and deselect the actual curve itself. And then I think I'll just add the tangencies in. So click on the curve to select it, hold down Control, click on the edge of the upper tube, make them tangent to each other. And again, if you sort of wiggle your mouse around, that menu disappears, but all the relation icons are available on the leftmost menu as well. So that menu that pops up is just to kind of make your life a little bit easier, just to speed up your modeling process slightly. So now I'll select this vertical edge. So I'll click on that, hold down Control, and then select the curve again. Do the same thing, add a tangency, and then you can see it has turned black. So the system doesn't need any more input from us. There's no need to dimension this. And if you do try and dimension it, so I'm going to try and put a dimension on it anyway, the system will kind of inform you that this dimension is not required, basically. And what it's offering to do there is it's offering to make this dimension something that's known as a driven dimension. So these dimensions up here, the two that we put on the upper curves, they're driving the size and scale of those curves. They're actually influencing the curve, and we can go in and edit those values and the curve shapes will change. So they're driving the curves. This one, the system's saying, do you want to make this dimension driven? So if we click on OK, you can see we can have that dimension in the sketch. It's a rather odd value. It doesn't kind of round nicely to a specific value. You can see there on the far left that I'm pointing at, that's what its actual value evaluates to. You can see it just goes on and on in terms of decimal places. It's actually been truncated down to 2 decimal places there, but yeah, this is now a driven value. So you can add these to your sketches, but you can't then edit them. They're just there for your information. So sometimes it's nice to use them, but in our case, I think we'll probably just delete it. So if you want to delete a dimension, I'm just going to deselect that dimension, just so I've got nothing already selected. And then if you just select it by clicking on the actual arrow kind of leg itself, don't try clicking on the value because the system might think you're trying to edit the value. Just click on that piece there, and then you can press the delete key and it disappears. So we've got 2 things to finish off in this sketch. Currently it's an open sketch, so I'll prove that now just by temporarily hiding all the solid bits of geometry that we've already created. So you can see there's a big hole at the top here, so the boundary doesn't get closed off at the top, and likewise at the bottom there, the boundary doesn't get closed off. So we need to address those 2 issues. And I think, given that we've not used this tool, we'll use the Convert Entities tool. At least I think we've not used it, but yeah, it's good to just make you aware that it's there and what it actually does. So what this tool allows you to do, we'll pre-select the tool by clicking on the icon, and then it's waiting for some input, and it kind of tells you, if you hover over the box, what it's waiting for, saying select faces or edges or sketch entities to convert. Now what that means is we can click on areas of our existing model. So let's say this top edge of the lower tube, or this front edge of the lower tube, or that circular edge of the upper tube, and we take a copy of them and we copy them into the current sketch. So what I'm going to do is I'm going to click on the edge of that upper tube and then click on the green tick over there to OK. And what you can see, although it's not immediately obvious, is we've taken a copy of that upper edge. So we've grabbed a copy of it and put it in the current sketch. Now there's too much geometry there. All of this side of the circle we don't require. We just want this side of the circle to complete our sketch. So I think we have used the trim tool before in other sketches. But if we haven't, and it's new information, that's the trim tool in the sketch toolbar, and it allows you to just, as my little animation's showing you there, it allows you to just freehand draw a grey line through any geometry that you don't want. So that's what that little animation is showing. you hold down the mouse button, and you just drag a freehand line through any other line in your sketch that you want to trim. And the way that the trim works is it trims that line back to its nearest neighboring line. So that's what we're going to do. So click on the trim entities. The type of trim, because there's a few different types, is the power trim. And this is kind of the one that we're going to use a lot when we use this tool. But luckily, it's the one that the system defaults to, the power trim. So I'm just going to, I'll create some wiggly shapes here just to show you that I'm holding the mouse button down and I'm just dragging this around, and then I'm going to hit the edge of this circle and watch what happens there. And then it gets trimmed back, and the trimming stops when it meets its nearest neighboring line, which is this arc up here and this arc down here. So that's the top bit done. We've closed off that end of the sketch. Now we've got to close off the bottom of the sketch. So I don't need the trim tool anymore, so I'm just going to click on the green tick to get out of the trim tool. And then I've temporarily hidden my solid tubes that I've created. You don't have to do that, but that was just to illustrate that this sketch was still open. So if we create an extrude and we just close off our sketch with a straight line there, there'll be a problem in that our extrude, well, let's do that. Let's do that first and we'll look at the problem. So let's get the line tool and just draw a simple line between that arc and that arc. And then we get our closed boundary shape and everything looks fine. So we then say we're happy with that sketch. So we exit the sketch. Then we get our preview. We change it to a mid-plane extrude. We'd give it the correct width, which, if I can find it, 20 mil is the correct width that we need. And then OK that feature, and then we'll investigate what's gone wrong. So we can see there, because we're doing a simple extrude on a mid-plane, but it's trying to join itself onto a tube shape. As the tube drops away, because it's got a circular cross-section, obviously, our extrude feature doesn't drop with it. It just extrudes outwards from a central plane, which was that right-hand plane that we created the sketch on. So there's a problem there. We're going to have to go back into that sketch and extend that bottom edge down into the tube a little bit more, so that when we create that extrude, it doesn't leave this missing wedge of material where the two don't touch each other, essentially. So yeah, let's do that. This is all good practice for going back into sketches that we've previously created. So we know the sketch is inside that final extrude feature there. So if we just select the extrude feature and click on the edit sketch icon there, don't make the mistake of editing the feature. So if you edit the feature itself, you'll be in that menu where you can set the depth of the extrude and the direction of the extrude. We don't want to do that. We want to edit the sketch that was created first, that's inside this feature. So edit sketch. I'm going to delete that bottom line. So press delete on there. And then what I'm going to have to do, I'm going to have to extend downwards, so down this edge to a certain depth, and then create a much lower horizontal line, and then create another vertical new line that goes up and meets that point there. So a valid question is, well, how deep into the part should we make this extra geometry? And I think the easiest way to do this is to go as deep as the inner wall of the tube. So that line there represents the inner wall of the actual tube shape itself. So we kind of know if we go that deep, we'll always create enough kind of overlap so that this feature and this lower tube feature will kind of weld themselves together into a single block of material. So that's what we're going to do. So I just changed my display style there to be, just let me get back to normal to the sketch. It's not allowing me to do it. Right hand plane, normal to, please. Oh, I've got the normal to icon right there. Right, so that's what I'm seeing. And it's because I've turned my display style to wireframe. So you can see the system's no longer shading in these tubes. It's just highlighting where the edges are. So the way I did that is inside that icon there. So if you click on that, all the different display styles are in there. And I've switched mine to the sort of transparent version, the wireframe version at the bottom. And it should be as easy as just getting the line tool and sketching 3 lines here. So from the end of that curve down to that inner face, and again, the system's offering me that coincident relation, so I know it's got to that inner face. So click there, horizontally along that inner face till I get to this plane back here, and then back up to meet my original sketch shape. And then it should shade the boundary in again. So I know that I've created a closed boundary. And this time, I know that the overlap's going to be enough between this feature that we're creating now and that original tube feature that the system is going to kind of weld the two of them into a unified block of material. So it's going to regard them as one single block of material, which is what I want. So I can OK the line tool, probably twice just to get out of it, and then OK the entire sketch just in the normal way, just with the blue exit sketch icon at the top right there. And then because I don't want to work in wireframe for the whole part, I'm going to turn my display style back to shaded with edges again. And then what I'm going to notice is, because I temporarily created 2 blocks of material, so when we had that wedge shape visible there, this new extrude that we were creating didn't actually touch that lower tube at all. It may have appeared as if it touched just slightly at the topmost extent of the tube, but it didn't. The two never overlapped each other. So the system set an option in here that would mean that this was always kept separate from the lower tube. And the reason I know that this is the case is that as I rotate around this, you can see there's a little bit of sort of graphical corruption, let's call it, where that face is actually occupying the same space as that face. And you can see the two are kind of fighting for supremacy there. So when I rotate round, that lower face of that piece of geometry that we just created is trying to break through the end face of this tube. And that indicates to me that the system hasn't unified these two into a single piece of geometry. It's keeping this one separate from this one. And if you ever get into that sort of situation in SolidWorks, you can check. So what I'm saying is basically I suspect that there are 2 solid bodies in this part. And the way that you investigate that is you go over to the feature manager, and if the folder that says solid bodies on it has got anything above a number 1, then you know that that's how many different bodies there are in your part. And what you can do is you can sort of drill down into that and have a look what bodies are in there. And if I select this one, it highlights what's included in that body. And if I select this one, it highlights what's included in that body. Now we will come to multi-body parts later on. Not today, but later on in the course, because it's sort of a concept that we can use to our advantage. But in this case, we intend for this part to be made out of a single piece of material. There should be no distinction between these two. So we need to correct this, is the bottom line. And it's an option in this extrude that we've just created that got switched on automatically by the system, and we've got to correct that now. So the upshot of all that is we're going to have to go back into that extrude feature and edit the feature this time. So click on the extrude feature icon in the feature manager. We're editing something about the feature, as I've just said. We're not editing something about the sketch, which is inside it. So feature, and the two key options are, we want this option ticked, which it is already, merge result. So what that means is whatever material gets created in this feature gets merged with all the other solid material that we've already created in the previous features. So that's good that that's ticked. But down here, where it says feature scope, it's only currently got this upper tube selected. So we could click on the lower tube and it will get added in there, or we can just switch it to all. And that basically means anything that this feature touches, it gets merged with. So all just kind of encompasses everything. So once we've set those options, ticked OK, then we get a rebuild, and you can see these two are no longer two distinct pieces of separate material. The system's essentially unified them into a single block of material that also includes the upper tube as well. So we've corrected that. Let's keep going. I think we'll do kind of an easy feature now. We'll just put that big fillet feature on that edge there, which again, I'm sure we kind of did a little bit on the fillet feature. The easiest way to initiate a fillet feature is just to click on an edge of the model itself. So the fillet is available up in the features toolbar, but by far the easiest way to get into that tool is just click on an edge that you want to apply it to. The quick access toolbar appears and the fillet icon is in that toolbar. Then you get a preview, and then I think what we'll do is we'll up the size to what it says on the drawing, which is 50. That preview still looks good. And then I'll rotate round and select that matching edge from the other side of the model, like that. And again, if you're not seeing what I'm seeing, two fillets previewed in yellow, you might have partial preview selected. So that only previews one out of the multiple ones that you've applied. So full preview shows you a full preview. So that looks good. So we'll accept that. Then I think we'll apply those much smaller fillets, which on our drawing that we're using for reference are all coloured in red. So we'll apply those ones, and these are all going to be a radius of 4, these ones. So we're going to select multiple edges this time. But I'll initiate the feature by just clicking on the edge of that tube there. So click on there, apply another fillet feature. You won't get a preview because it's still huge. It's still set at 50, which can't be applied to that edge because the edge isn't big enough. So we'll change the size to 4. And then it's just a case of going around the model and kind of methodically applying this fillet to all the edges that require it. So that little internal edge there needs it as well. And then, seeing as we've got those two, we could do their matching counterparts from the other side of the part. So if we rotate around, get the matching ones on that side of the part as well. And again, if you click in error on something, like let's say that face there, you can either click on it a second time to remove it, or you can find it over here in the sort of highlighted blue entry box and just right click on the thing that you don't want and say delete. Yeah, either one of those options will sort of get rid of it. So now I'm going to click on the kind of upper curve of that sort of spine shape that we've created. And when I do that, you can see hopefully what happens. That fillet, because all these edges are all tangent to each other, they all have tangency relations. So when one edge meets its neighbour, there's no nasty little notch between them or peak. One edge runs into the next edge perfectly tangent to it. So because I've got this option on by default, so I'm clicking it on and off now, what it does by default is if there are edges that are tangent to the current edge, it will just run all the way around them. So that's what it defaults to, which is arguably kind of the most useful way to set it up. So I'll click on the lower edge of that kind of spine shape as well. And I think we've got them all at that point. Yeah. So, okay, that one. And then, seeing as we're kind of tackling that fillet, it might be worth applying that specific red highlight color just to the fillet feature itself. So the way that you would do that is if you select the fillet in the feature manager over there on the left, or select any feature that you want to change the color of just that feature, and it's this icon here. So if we click on appearances, then we get the option. So what the system's saying here is this new color that you're about to set, do you want to apply it to the fillet itself, to the entire solid body? So we've already said we have a single solid body now. We did have two before we corrected that problem. So that would apply it to the full part in this case. Or do you want to apply it to the part as a whole? So in this case, we want to apply a color to just the fillet feature, which was the feature that we clicked on. So we'll click on that icon, and then it takes us into the appearances manager. So we've said we want a bright red fillet. So if we select bright red from the palette there, or any color that we want, we get a preview of what it's doing. It's applying it to just the fillet in this case, and then we can just click on OK. So you can do that with any feature, or you could change the kind of base color of the part itself. You can see, because I've got this this little rollout visible, so what I'm doing is clicking on that little arrow there. You get a nice little readout of how each feature is being displayed and whether each feature's got a specific color to it and all that sort of extra information if you have that little rollout visible there. And you can see now that there's a red appearance being applied to that feature specifically, but then there's the default gray of the part itself, which is there. So yeah, I like to have that kind of active, that little rollout. And you can hide and show things by just clicking on their icons as well. So you can see I'm going through the base planes then, hiding and showing them. So yeah, you don't have to work with that active. There's ways of doing it without that. And if you're running out of screen space, it might not be that useful. Anyway, let's finish this part off and then we can get on with creating the drawings of it. So there's one last feature to put in, and it's that keyway cut that we saw on the drawing. So it's that little cut there that is 14 wide, and then it has this kind of reference dimension that references the edge of the circle. That I'm sure we used the dimensioning tool the other week to, oh, maybe we didn't. Maybe I'm thinking of another group, but we'll tackle that in a second. So we're going to create this shape as an extruded cut. So let's do that now. So extruded cut is what we want to create. Now I've made a mistake there. I had the right plane selected already when I clicked on extruded cut. So it's assuming that I want to create the extruded cut sketch on the right plane, and I don't. So I'm just going to quit out of there. But if you ever do something similar like that, you can just cancel it. So I'm going to make sure I've got no faces selected. I'm clicking in empty space over here. Now I'm going to click on extruded cut. Then it's going to ask me for a face or a plane to sketch on. I'm going to select that face there. And then I know I want sort of a rectangular shape for this cut. And I kind of know I want to center it about that plane there, about the right plane. So it's a good bet that the center rectangle will be the kind of most suitable, because that allows you to place the center of the actual rectangle itself. Whereas the other common one, which is the corner to corner, I would have to do a bit of extra work to get that to lock itself into perfectly central around that plane. So center rectangle, drop the center point somewhere on that vertical plane there. So that will do for the time being. Drag it into sort of approximate position, so it's going to cut some material. About there will be fine for the time being. And then I don't want to create any more sketch lines, so I'm going to press escape to get out of the rectangle tool. And then what I'm going to do, because I want it to cut where it's overlapping solid material here, but then its lower extent, or this lower horizontal edge, I just kind of want to ensure that it always breaks through into this like central bore shape. So the easiest way to ensure that is to just lock it onto that plane there. So that's what I'm going to do. And rather than click on one of the points here and hold down Control and then click on the plane, I'm just going to drag one of these points onto the plane just by clicking and holding and dragging. And the system should offer me the right relation there, which is the coincident relation, which it is doing. It's highlighting in yellow, that little yellow icon. So let it put that in. Yep, that seems to have worked. It's locked onto the plane now. Yep, I can't drag it vertically anymore. So that's sort of end of the rectangle out. I'm going to get the Smart Dimension tool, dimension the width of it, which is 14. And then there's only one thing left to dimension, which is the position of that top edge vertically. That is like that. So again, I'm going to get the Smart Dimension tool, and this time I'm going to click on that horizontal edge, and I want to dimension it down to the lowest extent of this kind of circular inner face. But in order to do that, if I just click on that face, it dimensions relative to the center point of that circular face. So that's not what I want. So I'm going to press escape once to cancel that. So I've still got that top edge selected, you can see. So if I hold down the Shift key before I click on the edge of that circle, then you can see there, it allows me to dimension relative to the sort of furthermost extent of that circle. Rather than trying to attach that dimension to the center point, it allows me to dimension to the edge of a circle or the edge of an arc. It works with as well. So that's how you make it sort of change its behavior when it's dimensioning relative to a circular feature or a circular edge. So we want 55 for that, as it is in the drawing. And then we should be okay. Yeah, we've got a closed boundary. It's fully defined. It's definitely fully defined. It's reading as such down there. So click to OK the sketch. And then I think just in this case, just because we don't use it that much, we'll use the through all option. It is a crude way of kind of achieving what we need, but yeah, we'll use it. So click on the green tick, deselect everything just by clicking in some empty space there, and yeah, that looks okay. So that's the part complete. And just before we save that, if your system is showing the edges of these fillet features not with kind of a dashed font like mine is, if yours are solid, don't worry about that. It's just a system option. I was doing another tutorial in the week that just required me, how did I dimension it to the edge of the circle? Yeah, that always trips people up. Let me go back into that sketch and I'll do it again. So let me delete my dimension, drag it out of position a little bit, and then Smart Dimension tool, and then click on the horizontal edge first, and then before you click on the edge of the circle, hold down the Shift key, and then click on the edge of the circle with the Shift key held, and it will allow you to go to the edge of the circle rather than just default into the center point of the circle itself. Did that sort that out? Yeah, it looks like you're okay now. and then obviously OK the sketch, and we set it as through all, that feature, so it'll just cut through everything that it encounters. So yeah, if you're seeing solid edges to your sort of tangent points there, so basically that fillet's being created, and when the fillet ends and it runs into that vertical face, there's a tangency relation between the two. That's how fillets work in the system. The fillet always ends tangent to the face that it sort of borders. And I've just got my system set up so that whenever there's a tangency sort of transition between two faces, it uses this kind of dashed font to represent that. But yours might be showing them as solid, but don't worry about that. It's I'll show you how to change it later on, but it's nothing major. You don't have to worry about it. So I think we'll save that now. So you want to click on the save icon at the top there. So I'll hover over that for a second. Click on save. You want to give it a sensible name. So given the drawing that we're going to create is called offset link, so that's the part name. And then the slightly more descriptive name is offset linkage. But yeah, just call it offset link. So you just want to type that in there. Now, if I save mine, it'll shout at me and say, you've already got one of these already. Do you want to overwrite it? And I'll just click on yes. So we've created that part. And what do we want to do now? We want to start the creation process of the actual drawing itself. So ultimately, we want to try and replicate that as near as we can. So if you're looking at a part currently on your screen at any point, not just now, and you want to create a drawing of that particular part, the easiest way of doing that is just to go into the file menu, and you can see there's an option there that says make drawing from part. And that just takes the one that you've currently got open and begins the drawing creation process using that. I think when we briefly looked at drawings the other week, I kind of made you shut the part down first so that you know how to do it kind of the long way. And this would be the way if you'd done previous work on a different day, and then you'd shut the system down, and then you'd come in thinking, right, I'm going to create some drawings. You wouldn't have to load the part up first. You'd just jump straight into creating a drawing, and then the drawing dialog would ask you, where's the part that you want to create this drawing of? So let's do it that way for this one, and then for the next drawing we'll do it the slightly easier way. So make sure the part's shut down. Tell the system you want to create a new file, just like we did when we were creating that part. This time we want to create a drawing, so double click on drawing. We should be confronted by the system-wide list of kind of drawing formats that are stored within the SolidWorks installation. If you're not seeing the full list like I've got here, it should be quite long with lots of different format types. It's because you've got that box ticked there. So that filters them all down to just the ones that are in your kind of local standard. So in my case, it's BSI for British standards. So untick that because we want access to the full list. And this drawing was an A3 drawing. And I think the nearest basis that we can get out of the default drawing formats within SolidWorks for our final sort of drawing style here with this title box is ANSI A3. We could possibly use DIN A3 as well. But yeah, I believe my basis for that one that we're working to is ANSI A3. So select that, click on OK, and the system will go away and create the sheet for you. But currently it's empty. Is there a specific style we should use for our assignment? It's been said that a sort of a good basis is to look at the, is it 888 or quadruple 8 standard? I forget, the international drawing standard. I'm sure the British standard's been sort of harmonized with that. So they're kind of the same. But yeah, do a little bit of reading in terms of that standard. but I'm not going to be too harsh on that, on the marking of the assignment. My sort of watchwords are clear and concise and non-ambiguous for your drawings. So as long as they're clear, as long as there's no bits of your designs that are just left open to interpretation, so you've been concise, uh, and as long as as long as they're unambiguous. And what I mean by that is there's no room for interpretation of them. It's just you've fully documented the form and shape and tolerances and everything about your parts. I'm not going to hold you to a particular standard. But yeah, it's probably worth reading it about the. I'm sure it's 888. It's been so long since I've actually read the standard paper. But I assume, can you use the library online service for getting standards? Do you know how to do that? Because if not, that might be a first sort of port of call to try and figure that one out. Because what the library online system allows you to do is download all these standards that you would otherwise have to pay for. So it's quite a nice little tool to use, at least while you're a student. As soon as you're not a student, you don't get access to them anymore. So, yeah, have a little look at that. That would be my advice. Right, back to what we were doing. So, what has the system just done? It's created me a blank drawing sheet, essentially. And when I say blank, I mean it's not got any views or dimensions or anything to do with a part on it, but it has got the items related to the sheet format that we've just selected. So it's got kind of a border. In the case of the ANSI sheets, they've got this nice numbered and lettered border. So if you're talking to someone, let's say over a distance on Zoom or whatever, you can refer to a specific grid square within the drawing. So you can say like, I'm looking at something, it's on a detailed view that's in square 5C. So they know kind of roughly where to be looking. So that's quite nice. That's why they do it like that. And it's given me all the default kind of title block information. Now, this might be certainly with your drawings, you're not working in a drawings department in a firm when you do the project for this module. So all of this stuff here that details who did the quality assurance on your parts and who manufactured them are kind of irrelevant. So what I would say is make sensible decisions in terms of you can get rid of a lot of this. Maybe things like finish and material might be worth keeping, possibly weight, and little standard annotations like these, like unless otherwise specified, dimensions are in millimeters. Yeah, things like that. It might be nice to keep. Things to do with management of a drawing department, which is what this is all related to, probably not as useful, and just taking up space on your sheet that you could be using for drawings. So yeah, but we'll look at editing the actual sheet format a bit when we have laid out some views. So what is the system asking us? It's saying you don't currently have a part loaded up unless you've left your part open in the background. But I told you to shut it down so that we're all looking at the same thing. So it's saying there's no parts open in the background in SolidWorks. Can you browse the hard disk and find the part that you want to create a drawing of? So I'll click on browse. Then I should drop into the correct folder, but if not, you might have to find the correct folder on your machine. There's my part, offset link. So I'm going to open that up. And then what the system does is it auto accepts that. So I've just gone back one menu now just to show you. It's accepted that, and what it does is it rolls you on into the next menu. So it automatically clicks that next button, takes you into the next menu, which is kind of where we begin to lay out our views. So let's just have a quick look at our reference material again. So I would say, again, there's a decision to be made here in the same way that we had to make decisions when we were modeling this part as to how we were going to approach it. Looking at these views, this view is totally independent. It's not a projection of any other view it's just been placed on the sheet and set its sort of viewpoint relative to the part, just totally independent of these other three views. So we'll keep that in mind. That one is not related to any of these other views, other than it's of the same part. But in terms of its orientation, it's not related. These three views, I will kind of term that as your typical sort of tri-view layout of a part. And they're all projections of another view, essentially. But what you have to try and decide is which view is it most sensible to put in first. And I would say it's this one, because that view there can be regarded as a projection of this view, but looking down from above. So that gets projected upwards that way. And that view there, again, can be regarded as a projection of this view. So I would say this is kind of the first view that we want to put down on our sheet. And then we'll project upwards and create that one, and project to the left and create this one. So what I want to do is find that view now. Now, in order to do that, what I'd like to be able to see is what view I'm currently about to place, because what the system's offering me here with this rectangle that is following my pointer around is one of the standard views of the part. And in this case, it's the front view. So I'd like to see what that looks like, rather than just seeing its size relative to the sheet, which is what I can see now via that rectangle. I want to actually see a preview of it. So I'm going to click on preview. Now I can see the actual view itself, and that's not the correct one. So I'm going to click on these other options. So I've got right, left, back, bottom, top, isometric. So I'm trying to find the one that corresponds with that one, and I think I've just found it. So it's right. And then before I place it, I think I'd like to switch its display style to shaded with edges. So you can see when we were playing around with these display styles, when we were creating the part itself, the same icons apply to these drawing views. So you can see I was on one that's known as hidden lines removed, which was that one. That's what it defaults to with drawings. But in this instance, I want to change it to shaded with edges, like that. And then I'm going to click on the sheet to drop that view. And then I'm going to create the two projections of this view. And the way that you do that is just move your pointer away from the what we're going to term the parent view. So move your pointer away from it, and whichever direction you move in, you get another projected view away from the original. So you can see you even get sort of 3D, sort of isometric-y kind of views as well. But we want that one up there and that one over to the left as well. And then we don't want to project any more views, so I'm going to hit the escape key to get out of that automatic view projection kind of behavior. And then what I'd probably do is just reposition these a little bit, just to kind of make their positions a bit more sensible. And then I think we'll place the 3D one next. So we'll get all the views laid down first. And then we might mess around with the sheet scale, because I suspect the sheet scale is slightly wrong for us. And then we'll start applying some actual annotations and dimensions to the views themselves. So, because I've still got one of these views selected, I've still got this one selected. Actually, it was this one over here. What I'm seeing on the left-hand side of the screen here is all the options related to the setup of that view. So you can see that view's selected, and it's designated as being selected by the fact that it's highlighted in blue. So the little dashed rectangle that's around it is selected. If I select the parent view here by clicking on the dashed rectangle around that, that one highlights in blue. And then same with that one as well. And so I have all the options there to modify that view, but I don't currently want to do that. I want to add a fourth view up here, which is a more sort of 3D style one. So I want to hit escape, so haven't currently got any view selected. and in the first tab at the top there, which yours may be called Drawing, or it may on your installation of SolidWorks be called something else. I think it might be called View Layout, but it does the same thing. And if you click on it, you should be seeing more or less the same icons displayed as I can see there. So one of the icons should say Model View on it. And that's what we want to lay down. We just want to put a view of the model in that has no particular relation to any of the other views. It's just its own kind of view of the model. So Model View. The system then says, what part do you want to create a view of? So it's just confirming that we do in actual fact want to create a view of the part that we've been working on already. So offset link is there. So I'm going to click on next because I'm happy with that. Then I'm back on this screen again, so I could drop another view. I can duplicate views, which is not recommended. But again, I'm looking for a specific view, which is a more 3D kind of perspective. So the only one of these standard views here that is in 3D is that one, isometric. There are others down here, but of these quick access kind of icon related ones, there's only isometric that's good for this sort of purpose. And then again, I want this in shaded with edges. The display style, I want it shaded. I don't want it as a line view only. So I'll click on that before I drop it on the sheet. And then I just click to drop the view. And then I want to change a few things about it. So we're trying to emulate this drawing here. And the sort of angle that we're viewing it from on the reference material is not quite the angle that we're viewing it from on our drawing currently. So we want to change that. So I'll leave that on the screen for reference. And I'll select this new view if it's not already selected. And the way that you select a view is just click on the box that appears around the view when you go near it. So click on the edge of the box. So I've got that view selected now. And if I want to rotate a 3D view, it's that icon at the top. So I'll hover over it for a second or two. Don't mistake it with its next door neighbor, which is just to rotate the view. So if you imagine this view was a photograph on a sheet of paper, I could just grab it with my fingers and rotate it round. That's not what we want to do. We want to actually move our 3D place in space relative to the view. So 3D drawing view is what we want. And then when I go inside the view window here, that's now turned solid blue, and click with my left mouse button and hold and drag round, you can see I can just rotate round as if I was in the part modeling environment. But I'm using my left mouse button held down rather than the middle mouse button like we do when we're in Part Modeler. So I want something about, let's see if we can get it approximately right. Something about there. That's fine. Don't get too hung up about getting it exactly right. I think the only basis that I used to position this view was just, I wanted some sort of specular highlight there. You can see the shading on this view, kind of, there's a light hitting that tubular shape where it meets that fillet. So I think that's all I was going for on this. Then when we're happy with the angle that we're viewing it from, we can click on OK to OK that view. If we need to reposition it a bit, you just click on the selection box around the view and hold down the left mouse button again, and you can drag the views around to wherever you need them to be. And then when you let go, it just drops them back onto the sheet again. So the next thing that we're going to sort of address is that I suspect the default sheet scale on this reference image is different to the sheet scale on our sheet. And we can just ascertain that by looking at the title block. Default sheet scale is 2:3 as a ratio. So let's check and see what ours is. So 1:2. Yeah, it's different. So let's set the default scale for the entire sheet now. Now you can do this per view. We could manually go in and edit the scale of this view and edit the scale of this view and edit, but that's the long-winded way. That's not the way to do it unless you specifically want a view which doesn't follow the sheet scale, because that would also ensure that this label here was very confusing for the person reading this drawing, because they'd say, well, the default scale says it's 1 to 2, but all these views have been scaled differently. So that's not the way to do this. The way to do it is over on the left-hand side here. If you want to make a sheet-wide change to the drawing, you want to edit the properties of the sheet itself. So you can see all our drawing views are listed here. All the drawing views that we've created so far, there's 4 of them. They're all listed. They're listed in the order that we created them in. And then there's an option there which is related to the sheet format itself. So that would be the ANSI A3 sheet with all its border and its title block. That's what's related to that. And then above all those, at a higher level, so you can see they're all sub-options within the sheet itself. So the sheet at this point is the highest kind of feature, if you like. Everything else is a sub-feature of that. So we want to make a sheet-wide change. So we just right-click on the sheet, go down to Properties, click on Properties, and there you go. That's all the setup for the actual sheet itself. And we want to change the scale to 2 to 3. And another good thing to check while you're in here is that the projection type is correct as well. Because as I projected upwards away from this initial view, I got the view which is arguably looking down on top of the part, as we've kind of named the directions. So I'm looking down from above, and then when I project in this direction, I'm kind of looking inwards from this side of the part. And the reason for that is that I've got my system set for third angle projection. What I'm going to do now temporarily is switch it to first angle and see what effect that has. So switch it to first angle, apply, and you can see, hopefully, the projections are now looking from the opposite side of the part. So for our purposes, all our drawings are going to be set as third angle. So I'm going to now go in and change that back. So I'll press Escape to deselect everything, go back into the sheet, Properties, set it all back to third angle again. And you can see also, if at any point you want to change the sheet size itself, or the format of the border and the title block, you've got all those sheet formats available in here. So I could change to a different sheet format at any point and just apply those changes as well. But I'm not gonna. I still want the ANSI A3 landscape for this one. So we're back where we were before. So I'll just reposition these views a bit. Again, the behavior of these projected views is that they always keep alignment with their parent view. So you can see I can't drag this view left and right, and I can't drag that view up and down. But I can drag the parent view in all directions, and the other two follow it as well. So when you're repositioning things, you've kind of got to keep that in mind as well. Right, so we've put all the views in. Now I think what we'll do is add some annotations to these. So generally, regardless of whether the first tab on your installation of SolidWorks is called Drawing, I know some people's named slightly differently, but the first tab is essentially related to placing new views in a drawing. And there's various different types of view that we're going to look at in later drawings: section views, detail views, crop views, views with breaks in them. If you're doing a drawing of something that's incredibly thin but incredibly long, and it doesn't change in its center section, you can put what's known as a break view in. So yeah, these are related to creating of views, and the next tab along, annotations, is what it says. It's related to putting annotations onto existing views or into the sheet. So annotations are dimensions, written notes, balloons on assembly, drawings, surface finishes. You can see all the different options here. Center lines and center marks we're going to use quite a lot as well. But yeah, generally you lay some views out, then you'll move on to annotating them. And maybe you'll go back and put some more views in. But this is going to be where we're going to do the majority of our work, these two tabs. So, as I said, as we were creating the sketches for this part, we were kind of smart in the way that we did that, because a lot of the sketches, or virtually all the sketches, we stuck to dimensioning them, these sketches, in the same way that the drawing was laid out. So that's why we made a concerted effort to get that dimension reading as a radius rather than a diameter. And thinking forward as we were doing that, the reason for that was that we can then use the kind of import option within the drawing. We don't have to lay out all these dimensions again in the drawing. We can just import them from the sketches within the part themselves. So that's what we're going to do. Someone's just asked when we were doing the 3D thing, when I change my sheet scale, only my 3D view is changing in size. Right, okay, we'll have a little look at that now. So, as I said before, when we were playing around with scales, you can scale each view to any particular scale that you want. They don't have to follow the sheet-wide scale. So it sounds like yours may be set up like that. So if you zoom in and just check that your sheet is on 2:3, that would be the first thing, just so that we know what we're working with. And then I'll try and emulate now what you're seeing on your system. So if I select this parent view here, and then I go over to the left here, and I go down, and mine's using sheet scale, but you can then not use sheet scale and set it to a different scale. So that should have answered that person's question, I think. So now these three views are ignoring the sheet scale, which is set to 2:3. Yep, that's it. So yeah, just be aware of that. And the other thing is that because this is the parent view, when I change this, the default is that the child views follow the parent. But again, I can override that behavior. If I want to pick one of the child views, that one there, the projections, I don't have to let it use its parent scale. I could set it as a custom scale if I wanted. So let's have that at 1:1. So you can see you've got full control over that. But the default tends to be that you will use the sheet scale unless there's a good reason not to. So if you create a detailed view, then obviously the detailed view is an enlargement. So that is going to be set to a different scale. But yeah, let me set mine all back to use the sheet scale again. So where are we? Use sheet scale. There we go. So we're back as we need it. So back in annotations. So there are two ways to put dimensions on your views. The way that we're going to use now, as I say, is to import them from the actual model itself, from the 3D model, the part that we've created. The other way is to just use smart dimensions, which behave exactly the same way as when you put them in sketches, except when you put them in a drawing, you don't get the option of editing the actual value. All the system does is it reports back to you what that value is on the arc or the line or the distance between two edges or whatever you dimension. It just reports what that value is in the part. But we'll look at smart dimension in a little while. The first thing that we're going to do, as I say, is the import method. So we're going to import model items. They're going to come from the model itself. So if you click on the icon that says model items, and I think we'll tackle these views one at a time. So we'll tackle this one first. No, we'll tackle the main one, the parent view there. So you can see, because I already had that view selected because I've been messing around with the scale of it, what the system's done is it said, I accept that input, drawing view 1, and I'll enter it into this box here. Now you may not have had that selected, so that box might be empty, or you may have that ticked, which is telling the system, when I import the dimensions, I want you to bring them into every single view that I'm looking at. Now, as I've already said, we're going to tackle these one view at a time. So I'm going to unselect that tick box. I don't want to bring it into every view all at once. I want to target one of these views. So I'm going to deselect that. Then the system's asking me which view. So that's why it's highlighting this entry box here. It's asking for me to click on a view. So we're going to tackle this first view that we drop. So drawing view 1. So I click on that dotted rectangle around drawing view 1. It enters it into that box. What do I want to import? I kind of want to import all the dimensions that I used in the sketches. And by default, the system kind of selects that for me. So that's what this first icon is kind of doing. It says, or the long-winded description of it is dimensions marked for drawing. To which you might say, well, I didn't mark any dimensions for drawing. The default behavior of the system is all the sketch dimensions that you create all get marked for drawing import by default. So it's been doing that in the background as you've been creating them. So that's what it's going to import, all sketch dimensions. You can interpret that as. So the only thing left to set is, where do I want to bring the dimensions in from? Do I want to bring them in for the entire part, or do I want to bring them in for a specific feature that I'm going to click on the actual part itself? In this case, we want to bring them in from the entire part, so from every feature. So I don't want to select a feature. So that first drop down there where it says source, I want to change that to entire model. So in certain situations you'll use one, but in certain situations you'll use the other. And in this case, we just want to bring them from the whole model. So at that point, I should be able to tick at the top of this menu, and I'll get an import like that. Now, we've ended up with too many. We don't want all these on this view. But what we'll have to do now is just go through and delete the ones that we don't need, and maybe adjust the position slightly of the ones that we do want to keep. So you can see, you can just click and drag these around and keep the ones that you want to keep and get rid of the ones that you don't want to keep. So again, I'm using this view here as my reference. So I'm just dragging them into those approximate positions. So that radius 4 down there I don't need. So any that you don't need, just click on them and then press the delete key. So it's pretty quick in terms of a method to actually get these set up. So if you just want to copy what I'm doing here. Yep, that one's okay. Drag that one down a little bit. I think we've got them all for that view. So something else that you might notice is that the kind of appearance of these on the sheet that we're creating now isn't quite 100% what they appear like on the reference material. So I'll just get that on the screen. The reference style is arguably a little bit more legible. Locking all the dimensions so that the text is all horizontal is quite preferable on this drawing. There's little things to do with the font size and arrowheads, whether they're filled in. We're going to tackle all that in a second. We're going to bring all the dimensions into all the various views first, and then we'll edit something that's known as the drafting standard. So even though we've chosen an ANSI sheet format, our drafting standard, or certainly my drafting standard, is defaulted to BSI. And that's why we're seeing a slight difference between these annotations that we're working towards and these annotations that my system's sort of placed by default. But yeah, we'll tackle that all at once when we imported all the different annotations that we want. So let's tackle this top view next. So in this case, I am going to pre-select this view. So I want to click on the kind of box around the view to select it. So I've pre-selected it before I launch the import option again, the model items icon at the top. So click on model items. Now it should have accepted that view. Because I pre-selected it, it assumed that what I meant was I want to import these model items into a specific view, and that view. So we're happy about that. What do I want to bring them from? Entire model is still okay. Do I want to import them into all views? No, I don't. I want to import them into that specific view too. This is an important option. Eliminate duplicates. So what that means is any dimensions that I already have on another view, don't import those this time. So gradually we're making our job a little bit easier by not replicating dimensions that we've already got. So click on import, see what we get. Yep, that looks good. And we only want to keep a few on this view. So we want the 50, we want the 20, we don't want the radius down there. Do we want that one? No, we don't want that one. So yeah, that's essentially what we want on that view. We will come in, as I say, and edit these a little bit. So we might drag the positions a little bit further once we apply that drafting standard to make them look a little bit more like the reference image. So we'll do the final view, that one at the bottom left there, that we're calling the front view, although it might be the right. So select the view, pre-select the view. It's the quickest way of doing this. Click on model items. All the setup of this should be fine now. I don't think we need to play with any of these settings. We can just click on the green tick. And then let's... so we don't need the 4 there. We do want the 14, although it's a tricky one to place to make it legible. I think that's about as good as we can do. And we do want the 55. So there's one final one in here. It didn't really do a decent import on this view. So I'm clicking on this view at the top now of the radius of that fillet there. So what I'm talking about on our reference image is this annotation there. Now I may try that again, doing import model items again and seeing what version of that fillet it imports. But probably an easier way of doing that is to just use the Smart Dimension tool now. So this is the alternative method for adding dimensions to your drawings. If possible, I would try and use the model items method that we've just used for these views. But in some cases, or in the case of some features, it's problematic, or maybe the way that you drew the feature isn't necessarily the way that you want to dimension the drawing. That's often the case. The way that it's easiest to model a feature can differ from the way that you would like to lay the drawing out, the way that you would like to define the size and shape of something on a drawing. So in this case, we're going to use the Smart Dimension tool, which is the alternative method. And I'm just going to click on that little arc there and see if it agrees to place this dimension, and it does. So this is the other method. You can just use the Smart Dimension tool in the same way that you use it in a sketch. So let's say I'd not put that 50 in there. I could just, with the Smart Dimension tool active, click on the 2 edges that I required. Now you may be noticing that the system is now, all these smart dimensions that I'm entering, it's colouring them a slightly sort of grayer colour than the imported model item ones. Now, again, that's the default behavior of SolidWorks. It's trying to communicate something to me, the SolidWorks user, and it's basically saying, in the same way that you can have driven and driving dimensions in a part itself, you can also have them in a drawing. So this is regarded as a driving dimension, which is why it's coloured in black. But these ones that I've just added are just there to report what that size happens to be. I can't affect them. I can't go in and edit that value. Whereas a nice offshoot of importing these dimensions is that you can actually edit them even from a drawing. And the drawing will update eventually. There you go. So that's quite a nice, that's what's known as a bi-directional link. So the drawing itself, when you import the actual dimensions direct from the features out of the model, like we did with all these dimensions that are coloured in black, you, the user, have the ability to edit the part from within the drawing itself. I'll just do a refresh there. So you can see the parts updating there. So that's what the system's trying to tell me. It's trying to say, you as the user might want to know which dimensions are being driven, so which ones aren't editable, and which dimensions are actually driving the size and shape of the part itself. Now, if you were to print this on a normal printer, they'd all be coloured in black. So you only kind of see it on the screen version that you create. So that's why they are there. Now there's a 50 there. Do we want that on that view? Yes, we do. So you can see that big radius there gets its own dimension as well. So I've just dragged that into position. So I'll get rid of that 50. If you really wanted to do let's say a screen grab of this or something like that, and you wanted these to be coloured in black, there is a sneaky way to override what the system's doing here. Although you're kind of not required to do this either for your drawings for the project, but it's a nice trick to be able to know how to do it. And if you want to know, it's in options again, which I think we played with the other week when we were setting up how our sketches rotated round to be normal to the sketch. So if you go into options, and then within there, there's a system option when it loads up to do with colours. And if you go down this list until you see dimensions, you have got driving there, which are the imported ones, which are in black, and non-imported, which are driven, which are currently coloured in light grey. But if I wanted to force them to be black, and I didn't want that information as to whether they're imported or not, there you go. So you've got the ability to change them if you really need to. And I think if you're saving out PDFs, sometimes it's nice to have them all coloured in black. And that's how you would kind of achieve that. You go in there, dimensions, driven and driving, and you just set the colours of each one to whatever you require it to be. But I'm going to set mine back so I get that distinction between the two. I get that extra information. Right, how are we doing for time? I think we're just about running out of time. So take a quick save of that, and we'll drop back in and just quickly finish that off next week. And then I think what I'll do, in terms of the other part that we were going to tackle, I'm keen to move on to maybe a bit of simulation next week. So I'll probably supply you with this part already modelled. And we might just do a quick drawing layout, which should be really quick by then because we'll be good at it. And then I think we'll do a little bit of simulation after that. And maybe I'll leave you that to do in your own time, that final one. So yeah, take a save of what we were doing there quickly. And then it will ask you, do you want to update the drawing views? Just click on yes, that's fine when you click save. And then it will give it a name, which is the same name that the actual part has. I suggest you just OK that. You just click on save. And then mine will probably shout at me saying, do you want to replace the one that's already there? I don't, so I'm going to cancel mine. So yeah, we'll have to leave it there because I've got to start my next session. But yeah, same time next week, and make sure you take a save of that because we'll load it back in. Someone's just asked, when you change those options, does it remain as the new default? I believe it does. As long as you're using your own installation of SolidWorks, it should keep that as the default option then. So yeah, that's either a good thing or a bad thing, but it should keep it. As long as you're not using the virtual Windows login version of SolidWorks that I know some people were having to use because they couldn't install SolidWorks themselves. So yeah, if no one's got anything else, I think we'll leave it there, and we'll come back in on the same thing next week.